Hey, 7th grade. Missed you guys a lot. Sending love from Sky Ranch. But as I mentioned, we do have a video lesson today. It's going to be over GCF, or greatest common value, which some of you assured me you have talked about before. So I'm sorry I don't have a cool cutout interactive notebook page today, but you'll have to deal with us taking notes. So again, today we're talking about greatest common factor. And sometimes we abbreviate that as GCF. So, since you guys know this, the definition, GCF, is the largest common factor of two numbers. Really two or more numbers. Because we can compare two numbers or three, or really as many as I want. So there's two different methods to solve. And we'll just divide right down the middle of the page. Method 1. That is prime factorization. Hopefully you've seen this before. If you haven't, that's okay. It's when I have two numbers. So let's say I have 45 and 60. I'm going to do these in different colors just so I don't get confused. If you want to do that as well, that's fine. So here's 60 in pink. Maybe you can't tell. 45, if I break that down into all its prime factors, it's 5 times 9. 9 I can break down into 3 times 3. So 45 is equal to 5 times 3 times 3. Or we could say 5 times 3 squared. But if you want to leave it in this form, that is fine. When I do a factor tree for 60, I can break 60 down a number of ways. For today, I'm going to use the easy way, 6 and 10. 6 breaks down into 3 and 2. 10 breaks down into 2 and 5. So 60, if I write out all its factors, is 3 times 2 times 2 times 5. Or we could write it as 3 times 2 squared times 5. Now I compare these, and this is why I said we might want to leave it in this form with all the different things laid out. And I'm going to see what factors these two numbers have in common. So I see right off the bat that they both have 5s, and they both have at least one 3. Now there's not a second 3 over here, so I can't circle that, and there's no 2s over here, so I can't circle those 2s. So my common factors are 5 and 3, and 5 times 3 is 15. So my GCF of 15 and 60 is 15. So that was method 1, prime factorization. Method 2 is not unsimilar, but it's a little different. It's called repeated division. So method 2, repeated division. So this, I'm going to create a little bit of a chart. And I start out with my two numbers, 45 and 60. The first thing I can see is that this ends in a 5, this ends in a 0, so they both must be divisible by 5. 45 divided by 5 is 9. Good job. 60 divided by 5 is 12. 12 and 9, I see that these are both divisible by 3. So here's where I repeatedly divide. 9 divided by 3, is 3. 12 divided by 3 is 4. 3 and 4, there's no common thing to divide them by, so I must be done. And my common factors are over here in this column. Because I don't just want any common factors, I want the greatest common factor. I'm going to again multiply those two together. 5 times 3 is 15. Either way, I'm getting the same answer. To me, this version seems a little bit easier, although it is a lot more writing. But either way you want to do it is fine. I will accept either. If you have some other great method for solving these, feel free to use that. So it's not very often that we just have two numbers and we decide greatest common factor, done. There's a lot more uses for it. And one of those might be to reduce a fraction to simplest term. So we can use to reduce fraction to simplest terms. So if I have the fraction 14 over 42, I need to reduce that. So I can divide by 2 and then divide by 2 and divide by 2 and keep going if that's the route I need to go. Or it might be nice just to find the greatest common factor. And that way I can take care of the division in one step and not keep having to divide over and over again. Again, if I don't want to keep having to divide, maybe repeated division is not the method you want to use. But again, it's totally up to you. So, let's say I do it by repeated division. Here's my two numbers, 14 and 42. I see first off they're both divisible by 2. 14 divided by 2 is 7. 42 divided by 2 is 21. 7 and 21 are both divisible by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. These are both prime. They can't be divided any further. So I'm done. Now, these are my common factors. I don't just want my common factors, though. I want the GCF. 7 times 2 is 14. So I could divide top and bottom both by 14 and get an answer. If I choose to use method 1, which is the prime factorization, I would take 14 and I would take 42. 14 I know is divisible, or divides into 7 and 2. These are both prime, so I'm done. 42 divides into 7 and 6. 6 is 3 and 2. When I list out those factors, I list 14 as 2 times 7. I list 42 being equal to 7 times 2 times 3. Aha, these match, and these match. So these must be my common factors. I'm looking for the GCF. 7 times 2 is 14. This 3 doesn't have a pair, so it can't ever be part of that least, or that greatest common factor. So when I go to simplify 14 over 42, I can divide both top and bottom by 14. 14 divided by 14 is 1. 42 divided by 14 is 3. Notice 3 was what we were left with here and here. Coincidence? Not at all. So not only can you get a fraction to its lowest terms or simplest terms using GCF, you can write equivalent fractions with them. So finding the greatest common factor of two numbers, reducing fractions, writing equivalent fractions, that's all part of your homework tonight. There's one more type of problem that will be in your homework that we need to talk about, and that is solving for n. Now don't freak out, it is a little bit of algebra, that's why we're taking pre-algebra this year, but it's not too hard. So let's say, for example, I have 4/9 equals n over 27. What I need to do first is find the GCF of 9 and 27. For the sake of time, I'm just going to go ahead and do the prime factorization, because that's what I find easiest. So 9 divides into 3 and 3. 27 divides into 9 and 3. And again, 9 is 3 and 3. So when I line up those factors, 9 equals 3 times 3. 27 is 3 times 3 times 3. So I can see that all I need to do to get from 9 to 27 is multiply by an extra 3. Because these are a pair, these are a pair, this one's all alone. So I'll come over here. I'm going to multiply my original fraction, 4/9. I'm going to multiply top and bottom by that missing 3. Over here I get 9 times 3 is 27. Hey, look, that's the denominator I wanted. Up top I want n. 4 times 3 is 12. So in this case, n is equal to 12. So those are the 4 kinds of problems that will be in your homework. If you forget how to do any of them, feel free to come rewatch the video. It will be posted to my website. GCF is not something we're going to forget after we learn it. Again, this is pre-algebra. These are the skills you're going to need to take with you to algebra. So I have my algebra survival guide, and there's multiple pages devoted to GCF. I understand what a factor is, but what is a greatest common factor? Well, I'm hoping we could answer that by our first definition. Again, the greatest common factor of 2 or more numbers is the largest number that is a factor of both of those numbers. And it'll give an answer down here when you're working with 2 or more monomials. Monomials just means a number or one variable. It's just one term. So when you're working with something that is just one term, a monomial, you often need to find the greatest common factor because you want something that divides evenly into all the monomials. And this greatest common factor is the GCF. So it gives you 3 monomials here, 12, 18, and 30. The GCF would be 6, and 6 is the largest number that divides into all 3 of those. Over here we're working with monomials that have A's in them. Again, some of your homework will have letters. It's okay, don't freak out. So if I had 4a squared, 6a, and 2a, 2a would be the biggest. 2 is the biggest, or the greatest common factor of 2, 6, and 4. A is the greatest common factor of a, and a squared. And you can read the rest of explanation. These little bottom things I gave you cut out to put in your journal. The second GCF one from this algebra survival guide I'll share with you is going down and going through the steps of how to find that GCF. This book uses the prime factorization method. I think that's most common what you'll see in your algebra courses later on. So it's giving the example of 72, 90, and 108. They prime factor it. 72 is 2 cubed times 3 squared. 90 is 2 to the first, 3 to the second, 5 to the first. 108 is 2 squared times 3 cubed. Since 2 to the 1 is the biggest out of that we can take, out of this column, 3 squared is the biggest we can take. We can't take a 3 cubed because not all of them have 3 threes. And none of the other ones have 5, so we can't take that 5. Then 2 to the first, which is 2, and 3 squared, which is 9. Multiply them together, that gives us 18. That is our greatest common factor. If you look, you can do these GCFs down here. The answers are flipped over for extra practice. So this is something that's not going away, not this year, not next year in algebra. You will need to know how to do GCF.